In 1859, telegraph operators across America unplugged their batteries, and the machines kept working. Sparks jumped from the keys. Paper caught fire on the desks. Messages flowed down dead wires, powered by something in the sky. That same night, gold miners in the Rocky Mountains woke at 1 in the morning, convinced it was dawn, and started cooking breakfast. In Cuba, people looked up and saw blood-red light dripping across the tropics. Nobody understood what had happened. One amateur astronomer in a small English village had watched it begin 17 hours earlier through a telescope in his back garden, and he was the only person on Earth who knew where it came from. What he saw has since been called the most dangerous natural event our civilization can face. By the end of this, you'll understand why scientists quietly count the years since it last happened. So what did he actually see? Richard Carrington was 33, a brewer's son who had turned his back on a comfortable career to map sunspots. On the morning of September 1st, 1859, he stood in his private observatory in Red Hill, south of London, projecting the sun's image onto a screen to trace a huge sunspot group by hand. At 18 minutes past 11, two brilliant beads of white light erupted inside the spot. He assumed a stray sunbeam had struck the screen. He checked the equipment. The lights were on the sun itself. Within 5 minutes, they crawled across 35,000 miles of solar surface, then faded. Carrington ran to fetch a witness and came back too late. 11 miles away, another observer named Richard Hodgson saw the same flash. They had just become the first humans in history to watch a solar flare. A flare is light. Light takes 8 minutes. So why did the world only catch fire 17 hours later? Because the flare came with something far heavier, 1 billion tons of magnetized plasma, blasted out of the sun at over 4 million miles an hour. That journey normally takes 3 or 4 days. This one arrived in 17 hours and 40 minutes, still the fastest transit ever recorded. When it struck, the Aurora, which belongs to the Arctic, spilled all the way toward the equator. It was reported over Hawaii, Colombia, Jamaica, and Queensland. In Boston, newspapers described people reading print by its light at 1 in the morning. Sailors in the Pacific thought a neighboring ship was ablaze. And at Kew Observatory in London, the magnetic instruments swung so violently that their traces ran clean off the recording paper. Here is the part that should worry you. In 1859, humanity had exactly one piece of electrical infrastructure, the telegraph, and a storm found every mile of it. Across Europe and North America, wires surged with current nobody had put there. Operators were thrown from their chairs by shocks. Sparks set fire to telegraph paper in Pittsburgh. Lines went dead, then came violently back to life. Then 2 operators, one in Boston and one in Portland, Maine, realized their batteries were now fighting the storm rather than helping. So they disconnected them completely and kept sending messages to each other for 2 hours on nothing, but the current, the Aurora, was pushing through the wire. One wrote that they were working with the current from the Aurora alone. A planet's atmosphere was running a communications network, and nobody knew what they were dealing with. Fine, you might think. That was a world of copper wire and candles. We are better protected now. We are not. We are vastly more exposed. On the 13th of March, 1989, a far weaker storm hit Earth. In Quebec, currents induced in the ground pushed up into the power grid through the long transmission lines carrying hydroelectricity south. Protective relays began tripping in sequence. From the first fault to total collapse took 90 seconds. 6 million people lost power in the middle of a Canadian winter, some for 9 hours. The Montreal Metro stopped. The airport shut. Further south, a transformer at a New Jersey nuclear plant was cooked so badly it had to be scrapped and replaced. That storm was a fraction of Carrington's strength. The difference is that by 1989, the wires ran through everybody's home. And it is not only the grid. In August 1972, a storm from a single furious sunspot region did something that stayed buried for decades. United States Navy aircraft flying near Han La, off the coast of Vietnam, watched dozens of sea mines detonate by themselves in the water. The mines triggered on magnetic fields. The storm had set them off. That finding was only published in 2018. Then there's the one you never heard about. On the 23rd of July, 2012, the sun launched a plasma cloud every bit as strong as 1859's, measured directly by NASA's Stereo A spacecraft. It crossed Earth's orbit. Earth simply was not there yet. We had passed that exact point 9 days earlier. That is the entire margin. Physicist Pete Riley later put the odds of a Carrington-class hit at roughly 12% per decade. 12%. So what actually happens when one lands? The danger is not your phone. It is the extra high voltage transformers sitting at the heart of every grid. These are not shelf items. Many weigh hundreds of tons, are custom built to order, and can take a year or more to deliver. Geomagnetic currents drive their cores into saturation. They overheat, and the insulation fails permanently. A 2008 United States National Academy of Sciences report estimated that a Carrington-level storm today could cost between $600 billion and $2.6 trillion in the first year alone, with some regions waiting 4 to 10 years for full restoration. No grid means no water pumping, no fuel pumping, no refrigeration, no payments. In February 2022, a storm so minor most people never noticed dragged 38 brand new Starlink satellites out of orbit. That was a small one. Now the twist. Carrington is not the worst the sun has done to us, and it is not close. In 2012, Japanese physicist Fusimi was measuring radiocarbon in the rings of ancient cedar trees when she found a violent spike inside a single year, 774 AD. The only plausible source is a solar particle event perhaps 10 times Carrington's size. It has happened again in 993 AD and twice more in prehistory. Here is the strange gift. That 774 spike is stamped into every tree alive that year, everywhere on Earth. So in 2021, researchers found it in what the Vikings had cut in Newfoundland, counted the rings outward, and proved Europeans stood in North America in exactly the year 1021, for 171 years before Columbus. The same solar violence that could switch off our civilization is how we date it. Subscribe for more stories like this.